Hello everyone, and welcome to our 9.2 Pythagorean Theorem notes. And so today we're going to get started with talking about right triangles. So remember that by definition, a right triangle contains a right angle. And then those pieces, A and B, are the two short sides of the right triangle. Those are going to be called the legs. Those are the legs of the right triangle. A way that I remember that is that they form an L when you highlight them. Both of them touch that right angle, that they make up that corner. And so that looks like an L, and that reminds me that those are called the legs. So that's A and B. And the side opposite the right angle is going to be C, and that is going to be called the hypotenuse. It's going to be the longest side in that triangle. So C is going to be the longest side of the right triangle, lies opposite the right angle, and it is called the hypotenuse. So we have a theorem that is specific to right triangles. It is called the Pythagorean Theorem. And again, it's only used in right triangles. So what does the Pythagorean Theorem state? The Pythagorean Theorem states that a squared plus b squared is equal to c squared, where c is that hypotenuse. So c has to be that hypotenuse. The Pythagorean theorem is used to find a missing side length on a right triangle. So it has to contain that right angle, or you have to be told that it's a right triangle in order to use the theorem. So this is nothing new. This is what y'all learned in middle school, but there is one twist. It says, for directions, use the Pythagorean theorem, which y'all have learned before, to solve for the missing side length, but it specifies to leave it in simplest radical form. So remember, we're not going to be approximating decimals here. We're going to be simplifying our radicals and taking out perfect square factors. So we want it in simplest radical form. So your answer should either be a whole number or it should be a combination of coefficients and radicals. All right, so first what I like to do is I like to find my hypotenuse. So this is my hypotenuse, that's the longest side. So I'm going to plug this into a squared plus b squared equals c squared. It doesn't matter which one the x is. It could be the a or the b, but the 10 has to be the c. So I'm going to go ahead and fill in the 10. The 10 has to go right here. Okay, and then I'm going to show y'all in class today how to start saving time. X squared plus 8 squared equals 10 squared. We know that mathematically what we're going to end up doing to get x squared by itself is subtracting 8 squared from both sides. So your calculator can go ahead and do all of that work for you instead of you having to type in each individual piece. When you type in 10 squared using your squared button minus 6 squared, you're going to get 36. So if x squared is 36, I'm going to take the square root of both sides to get what x is. X is going to be equal to 6. The only thing I want you to do is make sure you plug that in and make sure that makes sense in terms of the picture. If this side length right here is 6 inches, that makes sense because it is less than 10, which is the hypotenuse. Okay, so I'm going to start saving time on some of these problems. All right, let's do this again. Let's change colors. Let's see, what is my hypotenuse? Now this time my hypotenuse is the x. There's my right angle. And so when I plug this in, that's going to be 5 squared plus 12 squared equals x squared. X squared is already by itself, so you can go ahead and just type that expression into your calculator. 5 squared plus 12 squared is going to give you 169. So 169 equals x squared. We've been working with our perfect squares this week so that we know that whenever we go to take the square root of both sides, that is one of our perfect squares. The square root of 169 is 13. Just make sure that that makes sense in terms of the problem. That would be, the hypotenuse should be the biggest side, and that is bigger than both 5 and 12. So again, I could have labeled this one A and this one B, or I could have done it in reverse. Because you're adding those, it does not matter which leg is A and which leg is B. All right, here's my right angle, here's my hypotenuse, so that would be 9 squared plus x squared equals 15 squared. A quick way to save time is to get the x squared by itself by subtracting 9 squared from both sides. So type into your calculator 15 squared minus 9 squared, and x squared is going to be equal to 144. So whenever you take the square root of that, both of those, that ends up giving you x equals 12. Does that make sense as an answer if x is 12 meters? Yes, because it is less than 15, which is the hypotenuse. Okay, so far we haven't had to, we have not had to take out anything besides we've had perfect squares. Like 169 was a perfect square, so it was reduced to a whole number. Same thing for the 144. So let's keep going and see what pops up that's a little bit different. So where is my right triangles? Right here. X is my hypotenuse, so 8 squared plus 7 squared equals x squared. Again, you could have done 7 squared plus 8 squared, same thing. Since x squared is already by itself, we're just going to add that together in our calculator, and we get that x squared equals 113. So x is going to be the square root of 113. So here's where you have to slow down and see that's not a perfect square. It would give you a decimal if you typed it in right now. So we're going to go through our perfect squares list, which I squeezed into the side over here, and we're going to see if there are any perfect square factors of 113. So you'd start at 100 and you'd work your way up. You'd divide them and see if you get a whole number. You're going to see if it's a factor. And you get all the way to the top, and the only perfect square that is contained in root 113 is root 1. And we know that that means it's just fully simplified. So my final answer is 113. I would, to see if that makes sense as an answer, type it in as a decimal. That's going to be 10 point something when you type it in. So just type in square root 113. It's going to be 10.63. That does make sense as an answer. 10.63 is bigger than 8, and it is bigger than 7. Okay? All right, let's do that again. Here's my hypotenuse. So again, I'm looking for the hypotenuse on this problem. 15 squared plus 18 squared equals x squared. So I go ahead and just type all of that in, and you get x squared equals 549. If x squared is equal to 549, then x is going to be equal to the square root of 549. Again, we want to see if that simplifies here. So is there a perfect square factor of 549? So you go all the way up the list. And so just to save time, we're doing this together in class and practicing this more, but just to save time, since we've already done a video on how to do this, your first perfect square factor, your greatest perfect square factor, is going to be 9. 9 times 61 is 549, so I'm going to break that apart into the square root of 9 times the square root of 61. So what is the square root of 9? That is 3. So my final answer will be 3 root 61. Let's type that in to see what that is as a decimal. Square root of 549 or square root of 23.4. And when I type in 3 root 61, I also get that same thing. So we know that that's a good answer because that is both more than 18 and 15 like I expected it to be. So 3 root 61. So that's the first one I've had that I've had to take out a perfect square factor where a radical has remained. Okay. All right, let's do this again. Here's my hypotenuse. Here's my right angle. And so I'm going to do x squared plus 6 squared equals 13 squared. Again, the math that you're doing there to get x squared by itself is you're just subtracting 6 squared from both sides. So in your calculator, go ahead and just do 13 squared minus 6 squared. And x squared is going to be equal to 133. So x is going to be equal to the square root of 133. If you type in the square root of 133, let's just check that. 11.532, it keeps going, but that does make sense because that's less than 13. So the only thing we have to do is make sure that there's not a perfect square that's living under that radical as a factor that I could take out. So again, you'd go to this list, you'd go all the way up the list trying to find the greatest perfect square factor, but I'm going to go ahead and give you a spoiler alert. This one does not have a perfect square factor besides 1, so that just means that it is fully simplified. All right, let's see. I think I'm going to leave those for y'all to do on your own. Let's see. No, we'll do this one. We're going to cross this one out. Y'all can do that one on your own later, or come see me if you need help with it. Let's do this one. So this one would be x squared plus 25 squared equals 30 squared. So again, here's my hypotenuse. So it's got to be the 30. So if I want to get x squared by itself, I'm going to do minus 25 squared from both sides, and I'm going to type that into my calculator. I want y'all to see one more where you have to find a perfect square factor. So we would type this in, and we would get that x squared equals 275. So x is going to be equal to the square root of 275. 275. Okay? So we're looking for perfect square factors that I can simplify from that. And so the first one that's going to work, the greatest perfect square factor, is I can break this apart into root 25 times root 11. X is equal to root 25 root 11. Why does that help me? Because 25 is a perfect square. That becomes whole number 5. So 5 root 11 would be my final answer for x. Okay. I do want you to see this problem. This one throws people off because no, this is not a 14 and 11. This is the square root of 14 squared plus the square root of 11 squared. And that is going to be equal to my hypotenuse squared, which is x. So this one's a little bit different simply because it has a radical as the leg length. Okay, so what are we going to do? Well, you can type this in your calculator just like normal, square root of 14, and when you square that, what happens is you get 14 back. That is because these are inverse operations. Taking the square root of 14 and squaring it, that's the square root of 196. So what comes out, that's just going to be 14. Those are inverse operations. So what happens here, this becomes the square root of 121, which is just 11. So that gives me 2 whole numbers. Those turn into whole numbers. So then x squared equals 25. So x is going to be the square root of 25, which is just going to be 5 feet. You can make sure that that makes sense as an answer. Square root of 14 is going to be 3 point something, and then the square root of 11 is going to be, let's see, square root of 11, when I type that in, I'll tell you just so you see it's different, 3.3. Square root of 14 is about 3.7. Both of those are less than 5, like I anticipated. All right, so the converse of the Pythagorean theorem. So this says if Q, then P. If Q, then P. What we just did was the Pythagorean theorem, which says if it's a right triangle, then a squared plus b squared equals c squared. So the converse of that says that if a squared plus b squared equals c squared, then boom, it must be a right triangle. If a squared plus b squared is perfectly equal to c squared, then it's a right triangle. Okay? So I'm going to draw this out. Okay? A, B, and C. So I want you to think about what happens if I make the c squared larger, if I increase the amount of the c squared. Well, what happens? Let me draw this way. What happens? That angle opens up a little bit more. As I increase the length of c, no longer is it a right triangle. This angle right here is going to be an obtuse triangle. So you no longer have a hypotenuse, because by definition the hypotenuse is across from the right angle, but that side length that is a c has forced this angle to be obtuse. So if c is greater than, if c squared is greater than a squared plus b squared, then it's obtuse. Okay, so let's draw that out again with a different picture. So what happens if I shorten the length of c and a squared plus b squared is greater? That's going to be smaller than a right angle, which is going to make this acute. So that angle right here is going to be acute, and that forces this to be an acute triangle. Okay? So if a squared plus b squared is greater than c squared, then it is going to be acute. If a squared plus b squared is equal to c squared, it's right. And if the c squared value is greater than a squared plus b squared, then it is obtuse. So here's what that means. Determine whether the following side lengths form an acute, right, or obtuse triangle. Without knowing anything besides 3 side lengths, I'm able to tell what kind of triangle will be formed without knowing anything about the angles. The 11 is going to have to be your c value. So we're going to plug this in and see how a squared plus b squared compares to c squared. So again, I'm just going to plug in the legs. I'm going to see how that compares to the hypotenuse squared. So when I do that, 8 squared plus 6 squared, 8 squared plus 6 squared is 100. 11 squared is 121, so which value is bigger? My c squared value is bigger. Since c squared, the value is bigger, that means that this opens up more. My c is larger. That means that this angle right here must be obtuse, which makes this an obtuse triangle. This is an obtuse triangle. Okay, let's do that again. You do need to make sure you're finding the c value. The c value is always going to be the largest one. So we're going to see how a squared plus b squared compares to c squared. So 9 squared and 12 squared. How does that compare to 15 squared? Well, 15 squared is 225. 9 squared plus 12 squared. Again, you can type that all into your calculator. That is also 225. So this is where these are equal. So what kind of triangle is this? This is going to be a right triangle, where your A and your B and your C are here. This is equal, and so this is going to be a right triangle. Without even having a picture of it, now we can draw one. Okay, and last but not least, let's do these values. Which one is going to be my C value? It's going to have to be the 15 because it's the largest. So how does 11 squared plus 12 squared compare with 15 squared? 11 squared plus 12 squared is 265, which is greater than 225. This is a squared plus b squared is larger than c squared is less. So what that means is that this is going to be an acute triangle. So if I wanted to draw this out, I could do something like this. 11, 12, and 15. This angle right here is going to be smaller than 90, which makes this an acute triangle. This is acute. All right, so your homework assignment is on the back. This is just a practice 9.2, and just make sure that whenever you're using the Pythagorean theorem, we're not using decimals, we're leaving them in simplest radical form.